Again, looking at the integrand, there's a radical, and the radicand, I would complete the square on it. So let's do that first. And by doing that, we're hoping to see something. And so that would be x squared plus 4x. And half of 4 is 2. When you square it, you get plus 4. Now, certainly I just changed it, so I had to take minus 4 to make it equivalent. Right, they're equal now. Then what I'm going to do is, that's a completion of the square. And what do you get there? You get x plus 2, quantity squared, minus 4. I'm going to make a trigonometric substitution. And that trigonometric substitution is going to make is going to say x plus 2 is going to be 2 secant of theta. And what's dx going to equal to? 2 secant theta tangent of theta d theta. Let's plug it in. Hopefully things will get easier. So what do you get over here? You get the root of, that's going to be 4 secant squared theta minus 4. And what's dx equal to? 2 secant theta tangent of theta. And that's d theta. All right, it looks much worse. I'm going to simplify. And what I'm looking for is I'm looking for the number part first. So I'm seeing a 4 here, a 4 there. I factor that out. That would square root of 4, which is 2. I see another 2 over here, so I'm going to factor out a 4 now. And what are you left off with? On integration, put a little star over here, indicating it to go back to x's later. It's going to be secant squared minus 1, which is the tangent squared. And then what do you get there? You get secant theta. And then you get tangent of theta. All right, square root of tangent squared. It does present some issues for me. I'm not going to worry too much about that. And I'll just simply say tangent of theta. So let's put this over here. And you get 4. Again, I'm calling this now. Whoops, sorry about that. Just a tangent. So what do you get? I get tangent squared secant. I write that down. Whoops. Again, repeat what I did over here. I combined those two and I got a tangent squared out of it. And let's take a look at that. So what we're going to do there. Well, I guess I would write the tangent in terms of secants now. I'll put that down for you. My star here. That's 4. And you get 1 minus. I'm sorry, not 1 minus, my mistake. Tangent squared theta plus 1 is secant squared. So it's secant squared theta minus 1. All right, little star here. And then secant theta. D theta. What do you get there? 4 secant cubed. This seems to pop up a lot in this worksheet, by the way. And minus secant of theta. We derived both of these already, and I would just simply reuse that. All right? So let's take a look, and let's write that down now. I got them written over here. And the reason I'm writing them down for you is that we derived this one already. And we derived this one already. So what I'm going to do is combine those two together and write that down. So let's write that over here. So what do you get? I'm going to have to jam it in. Again, we're moving over here. Equals, that's going to be, let's see, I got to be really careful now. So secant, you know what? I'm combining these two together. And I think I can do that. So I get secant of theta, tangent of theta, plus, this is over 2 now. And let's see what you get there. You get 3 of those guys. So 3, the natural log of the secant of theta plus the tangent of theta plus some new constant. And when I add C1 to C2, I'm going to call it C3. All right? Now what do you got to do? You got to go back to x's, and that's often problematic. So I want to make sure you know that we wrote it down over here, that I said the secant, or twice the secant theta is x over 2. Let me write this on the side for you. Okay, let me put on what I did over here. I did this. So I said secant of theta is going to be x plus 2 over 2. All right, let's keep moving along. And one step at a time. And I definitely need the tan of theta too. I'll put that down for you. And let's put a triangle down over here. I'm going to say theta. And let's see what you're going to get over here. So the secant theta is going to be the hypotenuse, which is x plus 2, over 2. And Pythagorean theorem for this guy over here. So, x plus 2 is quantity squared, minus 4, which is going to be x squared plus 4x. So I'll write that down for you. So the tangent is going to be this over here. All right, let's pop it in. It's a lot of work though, isn't it? So let's put this down. I'm going to put a c down over here now. Hope I can jam this in there. What's the secant of theta? X plus 2 over 2. What's the tangent of theta? The square root of x squared plus 4x over 2 plus 3. Oh, you know what? I made a mistake. I just saw it. And you may wonder where it's coming from. I'm going to correct it. I'm not going to redo the problem, by the way. I'm going to correct it. And I wasn't really thinking. I was adding things together when I should not have been adding those things together. So I want to point out that I made a mistake here. I added when I should have subtracted. And what do you get over there? The secant cubed minus, let's see, the secant cubed, and there's 4 of those, right? Gotta make sure I'm doing this right now. So it would be, let's see, get my eraser out again. I know I need to erase this over here. And secant cubed minus secant. So it's going to be minus 1. I'll put that down. And then I need to multiply it by 4. And I forgot to do that. Let's do that now before I lose track of that again, right? And what does that give you? 2 secant theta tan theta minus 2 natural log secant theta. I know I'm jamming this in there, by the way. Plus C3. All right, I think I did okay now. Let's start plugging things in now. What are you going to go over here? Let's see. The secant of theta is going to be x plus 2 over 2, but I'm multiplying by 2, so it's just going to be x plus 2 now. What's the tangent of theta? It's going to be the square root of x squared plus 4x over 2 minus twice the log. Well, it's going to be x plus 2 over 2 plus the square root x squared plus 4x over 2 plus c. I got to clean this up, by the way. All right, let's take a look. And I'm going to need a common denominator of 2. and you get x plus 2. And then you do the square root of x squared plus 4x minus 4 of these things down, of the natural log. And I'll write it down carefully. Now, what I noticed about this over here, there's a common denominator over here. And I'm going to call this thing C4 now. Because what I noticed, it's a log of a quotient. So it's really going to be, the log of, x plus 2, the absolute value. Let me write that down for you. Plus the square root, x squared plus 4x. But then it would be, minus a minus, but it's still going to be a constant. It's going to be natural log of 2. So I'm going to just integrate that with the constant and call it c, plus c. That's some new constant, by the way. Put a box in this over here. And I'm going to look at the key now and see how close we got. All right, certainly got the common denominator of 2, x plus 2. That's the same thing as x squared plus 4x, minus 4. I see the absolute value. I see the x plus 2. And that's the same thing as x squared plus 4x. So as advertised. Thank you.